the previous videos, we mentioned about the practical considerations when you design your reinforced concrete structures. You will need to consider for the inspections and on-site monitoring that you limit the variations among the design of the structural elements. This will be helpful for the supervisions as well as the monitoring of the construction process. With a good consistency in terms of the design of the structural element, it is easier for all parties to memorize the typical design of different types of structural element, and this can significantly improve the productivity during the constructions. Now we will proceed with our discussions in terms of the typical sizes of different types of structural element for the low-rise residentials and commercial structures. First, let us look at the size of the beam. We have 150 times 300, which is in the mode of mm, 150 times 450, 230 times 450, 230 times 600. The 150 beam width is meant for single layer of brick wall, and 230 is meant for double layer of the brick wall. This 150 times 300 mm beam size will be the smallest size that you can see in the industry. It is normally meant for short beams, typically less than 2 meters. You see this size more often under smaller rooms, such as the washroom or some small rooms on lightly loaded places. In fact, you can have more other size, which is dependent on your situations. Sometimes when the load is relatively high, you may require taller beam as long as the aspect ratio between the width and the height fall somewhere between 0.3 to 0.6. That would be a good ratio for a typical beam, where the beam performs quite okay under bending moment. The aspect ratio less than 0.3, the beam will be rather slender. This you have to consider for the other serviceability issues, not only the amount of reinforcement bar embedded in the section. Due to the slenderness of the member, you might have the problems of the lateral torsional buckling, or because of the depth of the beam relatively high, you might need longitudinal reinforcement bar to control the cracking on the surface of the beam. This will need to be taken into considerations if you use extremely slender beam. The beam ratio greater than 0.6 is typically not recommended. It will result in bulky beam section, which increase in terms of the width of the beam, provide quite a limited contributions in moment resistance. However, at the same time, the weight of the member increases significantly. This will result in drastic increase in terms of the amount of reinforcement bar required within the member. Normally, we will try to avoid to have the ratio more than 0.6, unless we have problem with the maximum allowable depth of the beam, as restrained by the ceilings or certain required headroom. In order to make the member pass, we have no choice but to increase the size of the beam by width. This is definitely going to be non-economical, as you will see a large amount of reinforcement bar are to be embedded in this section. Next, if you see a star here, this represents the most common size that you can see for different types of structural element, which if you are talking about low-rise residential structures, you will see most of the member, it will fall between 3 to 6 meters, and most likely it's going to end up to be 150 times 450 section. Next, we look into the columns. These are the typical size of the columns. The most common one, it will be 150 times 300. These are the column size just nicely embedded in the wall. It is unless when you have insufficient axial capacity, you may need to increase the size of the column. However, beyond 150 mm, let's say 175, it cannot be fully hid within the wall. You need to be aware of this, and most likely you require the consent of the architect to allow that areas to be pop out from the wall. Typically for low-rise residential building, 150 times 300 should be sufficient, and there are ways for you to distribute the load. If you found the capacity is insufficient, most likely the columns are quite further apart, you can hide more columns in the wall. Some may want to increase the size by 150 times 350 or times 400. This will make the columns to be rather slender in one axis, which 150 times 300 is already a slender column to one axis. You have to be careful with the bending moment. In terms of the axial capacity, increasing this 300 to 350 or 400 in fact does not significantly increase the axial capacity, but you may have concern with the lateral buckling or the slenderness on the smaller axis. You should design for the column carefully. Another one, when the ratio between the width and the height of the column is extremely large, 4 reinforcement bars at the corners might not be sufficient. Let's say now your length here is 400. Most likely you need another 2 longitudinal reinforcement bars to control the cracking on the longer surface of the column. Of course, the other sizes is also applicable. This is provided that you have to abide to the proposed sections given by the architectural drawing. There are proposed columns. You can follow the size given by the architect. If you wish to enlarge the column, you will require consent from the architect. Especially the exposed column, that means the columns not hiding in the wall, it will be considered a part of the aesthetic view of the structure. Sometimes the architect purposely have those exposed to fit their design. You are recommended to use the exact same sections as proposed by the architect. Next, we talk about the slab thickness. In fact, all these 3 thicknesses are quite common, which is dependent on the size of the slabs. There is no right or wrong in terms of the designing the slab. Some prefer to go for a large slab, which in return you will have thicker slab, while some prefer to have smaller size slab. In this case, 125 mm slab will be sufficient. There are pros and cons in terms of the selections of the size of the slab. The reason the engineers will go to big slab size, it is with the intentions to reduce the amount of the beam in the structure. You know that the fabrication process for the beam is more tedious, as it involves the fabrications of the shellings. The steel worker need to produce a lot of shellings, which if you use a larger size of slabs, by increasing the thickness of the slab, the workers do not need to produce the shelling, and the reinforcement bar just simply lay onto the slab, and then casting can be made. That means the strategy of the designer now is to use the materials to compensate the tediousness in the fabrications of the beam. And the quality of casting is also better because you have plenty of space in the slab as compared to narrow space between the reinforcement bar in the beam. There are also advantages. Of course, there are also disadvantages. That means you will expect higher degree of deflections caused by the slab, and you need to make sure that the slab is properly done. Some engineers prefer to have smaller slabs, This one is more towards the conservative considerations, where the beam can perform quite well under bending moment, carrying the loads of the slab, and quickly distribute the stress from the slab to the beam and quickly to the column until to the foundations. That means the retain period of the stress within the structures, it will be shorter. It goes straight to the foundations. And normally the more beam in the structures, that means the stronger the frame of the structures. This comes with the conservative considerations. It is purely dependent on the purpose of the designers. Next, we look at the stairs. Normally, the thickness of the stair. The thickness here is referring to the selectiveness without considering the footstep of the stair. And this thickness here should at least be equivalent to the slab. Some may be 25 mm thicker, depending on the effective spans of the stairs. A typical effective spans of the stair, it will be somewhere between 4 meters plus minus, and 150 or 175 should be sufficient. And you have to consider also when you design the staircase, whether do you have any mechanism to transfer the load from the landing beam towards the ground. If not, the stairway may behave as a cantilever, or the load will be supported by the joints to the floor plan of different levels. In this case, most likely you require a thicker staircase. Next, we talk about the pile caps. The most common one, it will be 2 unit pile and 3 unit pile. Sometimes you also see 4 pile caps. In fact, you can go for more, but when you have the pile cap with more than 6 units pile, most likely you need to pay attention that you might want to relook into your design, both at the key plank level, whether the columns are more or less equally spaced, and also you might need to consider the suitable size of the piles. And if you have very significant differences in terms of the number of the piles, let's say now you have some pile caps with 1 unit pile, while you have other pile caps with 7 to 8 units piles. Due to significant variations, probably you need to do some adjustment based on the 2 aspects mentioned, which is at the key plank level as well as at the selections of the pile size level. These are the typical size that you can see from typical low-rise buildings that are meant for the residential or commercial usage. Instead, there will be cases of uncommon size, which normally happens for a reason, which is due to some constraints. For example, you do not have sufficient space within the ceiling, and you have to hide your beam within the ceiling. In this case, sometimes you see an aspect ratios which is not within the recommended ratio. This can't help due to the limitations of the design. In this case, it is not common. Therefore, having 1 or 2 members not perfectly economically designed should be okay. It will not significantly hide the cost of the constructions. Your ultimate goal here is to ensure the entire structure to be of integrity, and the structures must be safe. Next, you will need to be mindful of the offset column. Because of the offset column, sometimes you will come to a situation that you might need an extremely large stump in order to support the beam, and then for the column to penetrate through going up of the floor plan, the size of the column reduces, providing the space for the offset distance. And this kind of design is also uncommon, and it's not normally happen within the entire project, probably a few columns only. The implications in terms of the cost of the constructions is not that big, we will consider those are the special cases. And normally this kind of special cases will be easily identified by the contractors. On this matter, you will need to have the detailing properly indicated to the contractors so that they know how to construct these uncommon shapes. There will also be switches meant for supporting the architectural thing, especially those things are not within the floor plan, which has a certain distance from the top surface of the beam or from the soffit of the beam. Then in this case, you might need to enlarge your beam section either to increase the height or to lower the soffit in order to hang these architectural things. There will also be the members which are predefined by the architect, certain special shaped columns for the aesthetic purposes, the concrete gutter, as well as for the facade. In fact, we mentioned about this in our previous videos, that you need to observe the cross sections of the building to determine the predefined shapes by the architect in terms of the gutter especially, or you will need to consider the necessity to hang certain architecture things. This is one of the example that you see there is a gutter here plus the architecture thing, which needs to be properly indicated while you are presenting the detailings of the structures. For example, this one, quite an awkward design, or something like this, and others. You will need to provide sufficient reinforcement bar and imagine how the structures to resist the load, that the reinforcement bar are meant to strengthen the member. Especially for this awkward shape, you will require the supervisions by the professional engineers to closely check the stability of the structures. You can't just simply propose the reinforcement bar, which if you put it wrongly, it may lead to the damage and failure of the member. If you are a fresh graduate engineer, when you encounter this kind of problem, no matter how confident are you with the design, kindly seek confirmations from the professional engineers to confirm your proposal is stable.